we have already discussed the difference between absolute and incremental mode of programming in lecture number 6. If you have skipped that lecture by any chance, please go back and watch it thoroughly in order to follow me in this and coming lectures. In this lecture, we will write a program using absolute mode. This is the product for which CNC program has to be written. In this, we have to maintain a diameter of 15 mm up to 15 mm length from this side, followed by conversion via taper from 15 mm to 20 mm diameter, and then we have to maintain 20 mm diameter for the rest of 15 mm length. The clamped area of the workpiece is not included. Now first, we have to identify what is required to be done. Is it turning, milling or drilling? This we have to decide first. In turning, the workpiece moves while the tool remains stationary. Whereas, in case of milling and drilling, tool moves while workpiece remains stationary. By looking at the required output, we can clearly state that it's a turning operation for sure. Now let's write the program with both absolute and incremental approach. Let's start with absolute first. The most basic difference between absolute and incremental approach is the uses of G codes. G90 is used for absolute, whereas G91 is used for incremental. The final shape that is desired is obtained by following Cartesian coordinate system for absolute approach. We will discuss this later in the lecture, but first we need to define the size of workpiece to undergo operation. In this case, we will need a circular bar of diameter 20 mm. This would be our workpiece. Now here we have to define a datum position from which tool will start moving. So this point here is considered as datum and the tool will be moving from this point O to 1 to point number 3 and point number 4. Now we will write the corresponding workpiece position and X and Z coordinates in a table format so as to have a mathematical deduction prior to writing the program. So for the starting point or the datum, the coordinates are obviously 0, 0. For point 1, the coordinates are 7.5 and 0. 7.5 mm is for x-axis and 0 is for z-axis. For point 2, 7.5 is for x and minus 15 would be for z-axis. For point 3, 10 would be for x and minus 20 would be for z-axis. And finally for point number 4, 10 would be for x-axis again and minus 35 would be for z-axis. The complete program for absolute approach is written here. Let's understand each line or each block one by one. Here, the first line depicts the program number. We can write it any number between 0 to 9999. In the second line, the first command used is G00 because rapid movement of tool is desirable initially. G21 command is used because to tell the machine that dimensions are in millimeter or metric units are used. If the dimensions were in inches or imperial units were used, G20 command would have been used. G54 is used to set offset. G90 is obviously used for announcing that the approach is absolute. G94 command is used to tell the machine that feet per minute is used. If in any case feet per revolution is desirable, we shall use G95. And finally the end of block, which is denoted by semicolon. This ends the block or line of the program. In the third line, we are invoking the tool change command M06. and changing the tool to tool number 01. So T0101 is also written here, followed by end of block. In the next line or block, we will switch on the spindle using M03 command, which would give a clockwise rotation. For counterclockwise rotation, we shall use M04 command. S1000 command is used as well to give spindle a speed of 1000 RPM. Now the machine has been started, so we are required to switch on the coolant as well. For that we use M08 command. The next line is G00 X11.0 Z0.5. Here 11.0 coordinate of x-axis is defined and not 10.0 because we don't want our tool dashing directly into workpiece. Same thing goes for z-axis coordinates as well. Now machining operation will commence, so G01 command is invoked, since it's obviously a linear interpolation, and the tool is shifted to datum by using command X0.0. We need to provide feed rate as well, so we will use F200 for 200 mm per minute feed rate. Now the tool has come to 0.0 datum position corresponding to x-axis, but it's still 0.5 mm away from datum corresponding to z-axis. So in this line, we are getting the tool exactly at the datum position by providing command Z0.0. Now to get tool smoothly to point 1, we need to first get the tool to one of the diametrical end of the workpiece. So for that we shall write X10.0. Now we will begin maintaining the 15 mm diametrical cut as desired by end product by giving command X7.5 followed by Z minus 15.0. Now again 20 mm diameter has to be maintained till 5 mm span in z-axis. So we basically need to propagate from x 7.5 mm position to x 10.0 position. For this we shall use the code x 10.0 z minus 20.0. Now the tool is in its final span, so we will simply write z minus 35 to finish the operation. Since the machining has been completed, we need to retract the tool via rapid movement and also to get the tool away from the workpiece. So we shall write G00 X 12.5 Z 20.0. To return to machine 0 position and return all the axes, we will now write G28 code followed by X 0.0 and Z 0.0. This will lead the tool back to the datum position. Since the whole machining operation is completed, we are now required to switch off the coolant using M09 code. And at the end of the program, we will write M30 code to end the program.